Was seeing your screen, was seeing the screen.
Okay.
You can see your screen, sir.
Okay, thank you.
So there was one person.
Now let's now move on.
And let become one.
So this is the sequence that I was explaining. So you can just take your paper too, and maybe you try this. Evaluate this 3i squared minus 5i. You can evaluate that. So you are taking from you are going to add the term of this series together. That is the meaning of sum here. High when I is 1, you get first term plus when I is 2, which second term plus the third term, fourth term, and fifth term. And that's what you see here. So because I appears, you can actually make this this sigma sign to be sigma of 3i squared minus that of 5i. Okay. So using the formula, you can take 3 out of the sigma, just as I said the other time, that will now be 3 sigma high square minus sigma 5 sigma high. The formula for sigma high is n into n plus 1 that we have just seen. And the formula for sigma high square is what is in the bracket here. So you can evaluate and get 90. So this some of the things that you can
Sir.
yes.
Sir, can you go back to the other side? Sir, okay, sir. Don't worry, sir. Don't worry, sir. It's my bad. Sorry, sir.
So you have this as exercise. These are simple things. Write down the first 5 times of the following sequence. Then you can find their 58th term. So 2, 4, up to 2n. So this 2n here, I'm talking about A. I'm talking about A here. This 2n is the general term. So, and you'll be able to list the first 5 terms. The same thing here. This is the general term given here. And this is the n term, as I said, Tn. The n term is given as this. So you can find T1, T2, up to whatever. If the n term is also given like this, you can find the term. Same thing with others. We need to move fast. Now, let's look at 2 important example of this sequence. Arithmetic sequence, or you call it arithmetic progression, and we will later see geometric sequence or geometric progression. So, in the arithmetic sequence, we want to look at rule for sequence. Please don't get confused. Arithmetic sequence is also called arithmetic progression, and that's what you popularly call AP. Okay, so we want to write the explicit rule for an arithmetic sequence. We want to get the recursive rule for arithmetic sequence, and we want to evaluate sum of arithmetic square, which you call the sum of AP. So, by definition, AP, arithmetic progression or sequence, is the one in which each term of the sequence is obtained from the preceding term by adding a specific number called the common difference. So, by this, when you have the first term, let's say our first term is A, then the next term will be you add what is called common difference to the first term. Your second term will now be A plus common difference, A plus D. So if you know the fourth term, you can get the third term. What you just do is that the fourth term minus common difference will give you the fourth term. So these are things that you should know about AP. Okay. Now, if AN and AN plus 1 are 2 consecutive terms of an AP with the common difference D, then AN plus 1 will be AN plus D. AN plus this, that is, this to get the next term, then you add it to the preceding term. So, for each of the following arithmetic sequences, identify the first term A and the common difference. Please, hello, mute yourself. Mute yourself. Okay. Who is Brand Omobola? Brand Omobola, please unmute and ask your question.
Sorry, sir. I just wanted to say that my phone battery is about to die, so can I be excused from the class?
Okay.
Thank you, sir.
Buy power bank.
For each of the following identify the first term. The first term is called A and the common difference. So let's say we have this first one. This first one. What is our first term? Our first term is 4.
4.
What's going to be the common difference?
5.
Common difference 5, 5, 5, 5, 5, 5,
Common
5,
difference
5.
will be second
Five.
term minus first term. Or you say third term minus fourth term and so on. So you can also do the second one and the third one.
The common difference is +5.
Okay.
Plus 5. It's also 5.
Yes, it's also 5. 5 for
Plus 5. Plus 5.
Please.
What's the difference between 5 and plus 5?
Hello.
Divide.
In the second equation, the common difference is -2 and not +2.
Sorry, sir, I can't hear you. Are you saying anything?
Sir, you muted yourself.
But we cannot hear you.
Okay. Now
now.
I've unmute. Please, the rest of you mute yourself. I've unmute myself. The rest of you unmute, mute yourself because your noise is disturbing me and will just end the class. I don't need any chorus response. If you want to talk, please raise up your hand. I will call you. If I don't need your response, I don't want talking from any corner. So the end term of arithmetic sequence is given by this formula. This is the formula here. Okay. So that is what I wrote here. And don't forget that at the end term, I said I will be using Tn. So An or Tn mean the end term. And it's given as A1 plus n minus 1d. So in order not to waste time, we don't need to prove that. Now, I want us to look at the following example. Let us look at this. Number 1, example 1. This is example 2. And this is example 3. Let's look at each of them. So now we look at here. Find the rule for the end term of 3, 7, 11. So I say raise up your hand. I don't interrupt my teaching. Raise up your hand and I will call you. So I will answer. I will give you time to talk, David. So this example 1 is here. Example 2 is written here. Example 3 is written here. So David, what is your question? David Akpenoy Bukoluwa, what is your question? Unmute yourself and talk.
My question is in the previous slide.
And the previous slide is still here. This is the previous slide.
Yes, that one, that A subscript N is equals to Dn plus C. So I didn't explain that part.
Okay, I will come to that. Don't forget that I define C to be A1 minus D. I define A1 minus D from this. Look at it from this definition, but let's just leave this one for now. You are going to see it in the formula that I'm going on. But let's take our Tn to be this one, okay, which we know. And this formula that you are asking is the same. But how we got to this level, we are going to see it. So find the rule. You need first term and you need common difference. That's only information that you can get from here. So then you use your formula. Your formula is to get the general, to get An or Tn, as the case may be. So you apply this. Your Tn is A1 plus n minus 1d. So substitute your A1, which is first term, that is 3. Then your D is 7 minus 3 or 11 minus 4 or 15 minus 4. Put it in that formula and you express your Tn to be this. So this is the general rule. for that AP. You can do this. Find the 14th term of the AP, 4, 7, 10, 13. So the 14th term means you want to find the T14 or A14. So in that case, your N will be 14. So looking at this, your A1 is 4. Your common difference is 7 minus 4 or 10 minus 3, which is common difference, this. And N is 14 because you want to find T14. So come and use the formula. So your Tn will be this. Okay? With this, you can do number 3. The third term of an arithmetic sequence is 8. And 16th term is 47. Find A and find D. So that is an exercise. It's a classwork that you should be able to do. Okay? Can you do that?
Yes, sir.
Yes, sir.
Yes, sir. Yes,
No,
sir. We
sir.
can do it, sir.
So just use the information you have here. Your T3 is given as 8, and you know the formula. So you get that like equation 1. Then T16 is 47. Then use the formula. That is equation 2. And both equations will be in form of A and D. Solve simultaneously, you get your A and D.
So I've gotten it.
Yes.
D is 3.
D is 3 and
A
A1
is
is
2. A is 2.
2.
D is 3.
Okay. So what you do is that
Make now calm down, Jerry.
this is what you do. Third term of an AP, that is A3 of an AP, is equals to,
A is
don't
2,
forget you
D
are
is
using
3.
the formula, you use the formula A1 equals my A1 plus N minus 1. Your N is going to be 3. N minus 1 D. Okay, this is the formula. But N is 3 in this case. You can just put 3 in place of N. Put 3 in place of N. So you have A1 plus 2D. That's equation 1. Then you have information about 16 term. So, and meanwhile, this is equal to 8. So you get equation 1. Then you can do equation 2. That is A16, which is going to be A1 plus 16 minus 1. That's going to be 15D. So, and that is equals to 47. So you now have these two equations simultaneous, solve it simultaneous. A1 plus 2D equals to 8 and A1 plus 15 equals to 47. You solve simultaneously to get your A1 and D. So that's what you do there. The same, this one is also very similar. A term of an AP, I call it classwork. Please, you can attempt this.
Yes, sir.
And let me know what you have. The A
Okay, sir.
term, the H term of AP is 25. The 12th term is 41. Get the rule for the N term. Tn is equals to, yes, you are doing it, A1 plus N minus 1D. So this is the formula you are using.
So D is equals to 4 and A is equals to -3.
A is minus
Ma,
3.
calm down.
Just type your answer. Which one is the chorus
As
answer?
in,
Calm
as
down.
in, he said does not want cross answers.
I'm going to sanction some people here.
Yes,
I'm
sir.
not asking you to find A or D. Write the rule. Write the rule for the
Sir,
N
the
term.
answer is 4n minus 7.
4n minus 7. So
Yes, sir.
that is the rule that you are asked to find. And you cannot use that to find anything. You cannot use the rule to find any term they ask, whether first term or last term. Okay. I won't go through this. I will not. The question that guy was asking the other time can be derived from here, but I'm not going through that. I just want to give you that if A1 is this, A2, A3, you write it recursively, then you have your AN to be this. Then from this, you can get the sum of the n term. That is, you want to add the n term together. The sum can be this. If you know the first term of your sequence, which is A1, and you know the last term, the first term and the last term. If you know the first term, sorry, I will use A, and let me use capital L for the last term. Let me call this one, okay. So let's say you have the first term to be this, and your last term is to be this. Then your sum can be is n over 2 into A plus the first term plus last term, which is derived from this formula. A is the last term, okay, and A1 or A is the first term. So I cannot just say my Sn, because you may be reading another text and you see Sn equals to n over 2 brackets A, the first term of your sequence, plus n, which is the last term of your sequence. Okay, so you can use that to form the sequence. And I'm giving you this example very quickly. Suppose I add you to find the sum of 1 plus 3 up to 19. You can add this together: 1, 3, 5, 7, 9, 11, 13, 15, 17. That is the odd numbers between 1 and 19. So you have this. If you want to add it together, that's what is just done here. 1 plus 19, 3 plus 17, 5 plus 15, and so on and so forth. So you just have 20, 20, 20. Everything will be 100. You have it as 100. But let us use the formula I give and see whether we are going to have the same. Sn equals to, how many terms are here?
10.
There are 10. That is the sum of the first 10 number is going to be n over 2, which is 10 over 2, into, what is the first term? 1.
1.
What is the last term?
19.
19. What will this give you?
100.
100. So you can see 10 over 2, yes,
Times 20.
which is 100. So that is it. So you can see the formula is valid. Now, a short exercise. Find the sum of the integer from 1 to 45. What will your answer be? Sum of integer from 1 to 45. David, put down your hand.
Don't talk.
1035.
1035.
Okay. Okay, what's your question? Okay, yes, thank you. So it's just 45 2 times 1. Okay.
1035.
Now let's move on. Just this formula, which I wrote as Sn is n over 2 into A plus L, where L is the last term, is the same as A plus An. Now, if you know last term or An to be A1 plus n minus 1d, I can substitute L inside this place, or An inside this place, and simplify it, which is what I did here. N over 2 into A1 plus An, n over 2 into A1, this, our An is A1 plus n minus 1d, equals n over 2 into 2A1 plus n minus 1d. So this formula is very popular as the sum of the first n term of AP. In fact, if you don't know the last term, if only information you have is the first term and the common difference, you can use this is the formula you use to find the sum of the n term. But if you know the first term and last term, then you use the formula Sn equals to this. But if you don't know the last term, you know the first term and common difference, you use this formula. So they made the same. You can see the way the formula was derived here. So with this, you should be able to solve this. I'm just because of time. Find the sum of the first 15 terms of the arithmetic sequence. 4, 7, 10, 13. Find the sum of the first. So what are we going to do here?
Common.
You use the formula in
Oh, we
which
get
we
the
don't
common
have
difference.
our last
We use
term.
the formula.
Olajide Marvelous.
Yes,
Talk.
sir.
Now,
We
what are we
use
going to do, number one?
we use the formula in which we
What
don't
is
have
the
our
formula?
last term. That's n over 2, n
Mhm.
over 2, 2a plus n minus 1d.
Okay. Yeah, we are going to use the formula Sn equals to n over 2 into bracket 2a plus n minus 1d. The reason is that from this information we can find a and we can find common difference. So a and d will be known. We don't know the last term, so we cannot use the formula n over 2 into a plus l because we don't know the last term. So we cannot find S15. Then for number 2, find the sum of all numbers from 50 to 256.
This is 1015.
The sum of all the numbers. So we know A. What is our A? 50.
50.
50.
We know the last term. It's 256. But do we know N?
Yes.
Yes.
Yes, sir.
And what is our N?
206.
206.
207. 207. 207. 207.
256 are included.
So it will be 207 because 50 is inclusive. So if you add 256 minus 50, 256 minus 50, you add 1, so 57. Okay. Number 3, find the common difference and 20.
Sir, I don't understand those. Sir, can you go back to number 2?
Number 2.
Yes, sir.
Find
Yes,
the sum of all the numbers from 50 to 256.
So how do you not get the answer as 206?
I
I mean
didn't say the answer
207.
is 206. So you want to use, they said, from here, your A, to be 50.
Yes, sir.
Right?
Yes, sir.
And your L. What is your L?
256. 256.
What is common difference?
Common difference.
Common difference. There's no common difference.
There's no common
There's
difference.
no common difference, sir.
Common difference is 1 now.
You know the common difference now.
difference of 1.
Counting numbers.
1.
Common difference will be 1.
Common difference is 1.
So only what you don't know, you want to find the sum of the number, but you don't know N.
Okay.
So 50.
Okay, sir, don't worry. I'm now eager to understand 207. Sir, don't worry.
Sir, please explain how you got hen. Please explain.
Find N.
Yes.
Now, how many
noise now.
number? This one is by observation. Number between 50 and 256. 50, 51, 52 to 200 to 250 to 251 to 252 to 253 to 254 to 250. How many numbers are there?
Don't know. Sir, continue, Jerry.
So that's
206.
It's simple subtraction now.
206.
206.
207, bro.
It's not 206, it's 207 because we're starting from 50.
7 including 50.
Yes, we're starting from 50.
When you minus,
Okay,
Yeah.
56 minus 50.
I will send some of you out
Then
of this
including
platform.
the number 50.
I will send you out of this platform. I will send you out of this platform. Femi Ogundari, I will send you out of this platform, and the rest of you, I will send you out of this platform. I will send you out of this class. If you cannot maintain a decorum here, we send you out. If I ask you how many number between 1 and 10, maybe you will tell me it's one number between 1 and 10. Maybe you will tell me it's 9. Counting number between 1 and 10, you say it is 9. Is it 9? So counting number between 50 and 256.
207.
So that is how we got 9. And you can use any of the formula you move on. So for number 3, you find the common difference and 28th term. So you can find the common difference. And the 28th term of sequence is just T20. Once this is known, use the formula of Tn, which is A plus n minus 1D. The same thing for A and B. The third and 28th terms of an AP are 7 and minus 18.5, respectively. Find the first term, common difference, and fifth term. So just like what we did the other time, first term, 2 simultaneous equations is what you are going to have here. Should be able to do that. The same thing, number 5 and to number 6. Given that these 3 numbers, 2 minus 3k, 2k plus 3, k plus 7, are consecutive terms of a linear sequence. Another name for AP is linear sequence. Okay, find its common difference. You should be able to do that. You know the common difference. If they are consecutive term, common difference here will be second term minus first term, or third term minus second term, and must be equal. So you equate it and make k the subject. So once you get k, you should be able to find what the value is. So with this, yes, Emmanuel Akinyemi. Emmanuel Akinyemi, unmute and talk. Emmanuel Akinyemi. Okay, you don't have a question any longer. Now let's move to. Please, you don't need to help me call him.
Okay, sir.
Fausat Fasasi. Fausat Fasasi, please, your question.
Yes, sir. Yes, sir. I want to take us back to number 2. I didn't really get that. My network went. So, did you say the common difference is 1, sir? That one that says that the first time is 256.
Yes. What if write the counting number between 50 and 256? What is the first number?
1.
50. Between 50 and 256.
Oh, okay. 56, sorry.
What is the first number?
56, sir.
From 50 to 256, what is the first term?
From what? What did you say, sir?
Look at the screen.
Hey,
All the counting numbers between 50 and 256. Counting number
from 50. I cannot hear you.
Sir.
I can't hear you again, sir.
No, I'm not going to fly.
Hello, sir. We can't hear you again.
Yeah, Levi should log out again for the second time.
Lexi.
Okay.
Alpha.
I did.
Just the boss.
Lexi.
You guys, where's our teacher, please?
Go and look for him now.
That's a studious response.
I'm sorry. Please, who has the course outline, please?
What's up now? We don't come out in how many years?
Kindly send.
Okay, no problem.
Why are people leaving the group?
Invisible number.
One is
Check
5,000.
your DM.
My airdrop onto you now.
Olamide, is that me?
Invite
Hello?
your friends in space right now.
Hello?
Hi.
Hello, sir. You can hear me, sir.
Okay.
We can hear you, sir.
Okay. So I'm to geometric progression now. A GP is the
Yes,
one.
sir.
A GP is the one in which each term of sequence is obtained by multiplying the preceding term by a constant number, which is called common ratio. That constant number is going to be denoted as R. Okay. So, which means here you have a first term, you multiply with a number. So when you obtain second term by multiplying with that number, let's say your first term is A. So to get second term now, if common ratio is going to be R, the second term is going to be A multiplied by R, AR. The third term is going to be AR multiplied by R again. That is AR times R, AR square. So that this is how you get a geometric progression. And if you have two consecutive terms of your GP, you can actually find your R. So R will be a term divided by the preceding term. Your R will be third term divided by second term, fourth term divided by third term, and so on and so forth. So that is what I'm explaining in this part of the notes, what you see here. So that is what is being explained in this part of the note. Now, for each of the following geometric sequence, identify the common ratio. If you have 3, 6, 12, 24, 48 as geometric sequence, what is the common ratio? Common ratio will be
2, sir.
2. So a term divided by the preceding term. So if I take 24 now, ratio R will be 24 divided by 12. If I take 48, it's going to be 48 divided by 24. The same thing, number 2, 7, 7 over 2, 7 over 4, 7 over 8.
Yeah.
My common ratio is going to be 7 over 2 divided by 7. Or I say 7 over 4 divided by 7 over 2. Or I say 7 over 8 divided by 7 over 4. I will get half. So I will get this half. The same thing, you can try this. So the common ratio is going to be 1 minus half divided by 1. It's going to be minus half. Or 1 over 4 divided by minus half. Or minus 1 over 8 divided by...
That's minus half.
That's minus. So common ratio in this case is going to be minus.
It's minus half.
Good. So now let's look at this with the definition of GP. At this geometric progression, number 1.
2.
Number 1 is a geometric progression. What is the general formula?
Yes, sir.
What is going to be the general formula of this?
AR is power n
AR to power n minus 1.
Yes, but now before that formula, the way we did sequence, and we are looking, you know, when we started a sequence and the general formula for the end time of a sequence. 2n. So you can use that formula, AR raised to power n. This is what you will have. Okay?
Yes, sir.
For the end, the formula has not been given for the end term. It's not the sum. How do you the end term of this?
Sir, but I don't understand. Sir, how is it 2 raised to power n?
No. That's what I'm looking at. This is not 2n. This is 2n. It's not 2 raised to power n, it's 2n.
No, sir, it's actually 2 is mine is actually correct, sir.
It's correct,
Okay,
sir.
good. 2, 1,
Yeah,
2, 2,
correct.
2, 3, 2, 4.
So it's to
Yes.
power
What about the
two.
common ratio?
No, just hold on.
It's
So it's
correct,
What
sir.
about the common ratio?
it is two.
Common ratio
That
is
is A.
2.
A.
So
2
how is
times
it
2 raised to
Okay,
power
the
n
A,
minus 1.
what of the A?
Common ratio is
The
2.
A is 2 now.
Hey,
So it's
hello.
supposed to be
Yeah,
4 raised to
bro.
power n.
now.
Stop the correct answers now. Chill.
that one?
I will just leave the class for you. Those people that are just talking anyhow. Look at this. The first term is A. Meanwhile, here I've not introduced the formula that you even mentioned. I've not introduced it at all. I'm just talking about the common ratio that you know. Yeah, we want to look at the nth term without going through the formula of a geometric progression. Now, how do you see this? This one is the first term is the A1 is 2, A2 is 4, A3 is 8, A4. So from here now, if A1 is 2, and you can write this A1 to be 2 raised to power 1. Look at A2. A2 is 2 raised to power 2, right? A3 is 2 raised to power 3. A4 is 2 raised to power 4. So if you want to look for the next, that is A raised to power 5. So in general, Tn is 2 raised to power n. So it's not a matter of the formula now. If you use the formula, you must arrive at this. But we are not talking about the formula for now. Use the formula, you will arrive at this. If you want to use the formula is this. Tn, I've not mentioned the formula, but let me just show you to avoid doubt. Tn is AR raised to power n minus 1. This is the formula. Your A is 2. Your common ratio is also 2. 2 raised times 2 raised to power n minus 1. By law of indices, is it not 2 raised to power n? Okay. But let's say we don't even know this formula now. You can find the nth term here because the first term is 2 raised to power 1. Second term is 2 raised to power 2. Third term is 2 raised to power 3. Fourth term is 2 raised to power 4. Fifth term is 2 raised to power 5. Then the nth term is going to be 2 raised to power n. Let us look at this. 2, 36, 108. We are not using the formula now, but if you want to use the formula, this is what you are going to get. But here, let us look by observation. 12. 12, what is common to all of these? You can see 4 is common. 12 will be, are they with me? Are you hearing me? Okay, good.
Yes, sir.
Okay.
Yes, sir.
12 is, yes, 4 is 4 times 3. You can see 36 is 4 times 9, which is 4 times 3 raised to power 2. 108 is going to be 4 times 27. And I think this one also should be like that, if you look at it by observation. So we can now see, since this one is 4 times 3 raised to power 1, and the second term is 4 times 3 raised to power 2, and the third term is 4 times 3 raised to power 3, and so on and so forth. So the end term of this cannot be 4 times 3 raised to power n. And that is how you got this. If you apply this formula, yet we have not introduced this formula, but if you apply this formula, you will still get this. So the same thing to number 3. You have this one is just square. 1 is 1 raised to power 2, 1 square. 4 is 2 raised square. 9 is 3 square. 16 is 3 square. The next one is going to be 25, which is 5 square, and there is just n square. Then this one, yep. If you look at this is minus 1 over 3 raised to power 2. This is minus 1 over 3 raised to power 1. 1 over n is minus 1 over 3 raised to power 2. So you have this. Here's what you have. the general formula. And when n is odd number, you have negative. When n is even number, you have positive, because minus 1 raised to power positive number gives you positive 1. Minus 1 raised to power negative number gives you negative 1. So, looking at the time, okay? So the n term, now let us look at the n term of a geometric sequence, which I have just mentioned. The n term of a geometric sequence with common ratio R and first term A1 is this, which is I call Tn, but An here. A1 R raised to power n minus 1. Any difference between these? I think just repetition is the same thing. Okay, where n is greater or equals to 1. So I can use A to be A1, so don't get confused. Example, find the seventh term of a GP, 4, 20, 100. Find the seventh term. So we are going to use the formula AN is equal to AR n plus 1. So seventh, or you call it Tn. Tn AR. So which means you want to apply this formula, you are looking for 3 things. You must know your A, which is first term of the GP. You must know R, which is the common ratio, and you must know the number of terms. So now we want to find T. You want to find 7 terms. That means you are looking for T7. In that case, N is 7. Then look at the sequence. A is 4. Then you can find the common ratio, which is 20 divided by 4 or 100 divided by 20. So that's what you have here. A is 4. N is 7. Your R is 20 over 4. So apply this formula. So you have A7, which is going to be 4 times 5 raised by 7 minus 1, which is 4 times 5 raised by 6, which is 62,500. Okay. Can we do this as practice exercise? The first one, the second term of a GP is 18. The fifth term is 2 over 3. Find the rule for the nth term. Can you attempt that very quickly?
No, sir. No, sir. No.
Yes, sir.
Okay.
Wait, sir, is that minus 18 or 18?
I think it should, the second term of a GP is, I think it should be 18. Let's.
So Tn is 54 times 1 over 3 raised power n.
Yes, let's use minus 18 here. Minus 18. I'm expecting the answer to be 54 times minus 1 over 3 raised power n minus 1. The solution is at this side.
Sir, I don't understand, though.
Okay. The solution is at this side. For the first one, we want to look at this formula. We want to look at this formula. Oh, sorry. We are using this formula. Okay. Now, if the second term of a GP is 18, the fifth term is 2 over 3. What is the rule to find the nth term?
So it's 18, not minus 18.
It's 18. Okay.
Yes,
okay.
sir.
Let's say 18. Now, not minus 18. Thank you.
No, it's minus 18.
For those people that have done it. Okay. Yeah, let me. Okay, before we move on, Romosele, Aburume, you want to ask a question?
Sir.
You raise up your hand. Are you asking a question?
Yes, sir. No, that was the
Please.
question I wanted to ask, sir. That was the
Okay.
question I wanted to. I don't understand.
Okay, I will go that again. Who is Owen Agobe?
Sir, on slide 27,
Hello,
I
sir.
have a question there.
Slide 27. Okay, we are coming back to this, but I just want to settle the question.
Okay, sir. Okay, sir.
Hello,
Right?
sir.
Yes, Owen, I'm
I
here.
think I understand.
You understand now? Okay.
No,
Thank you.
Akin, I think I understand the question.
Okay. Okay, we are now slide
Can I
20.
explain what I solved? Can I explain what I solved?
Okay, explain. Who is
Okay, sir.
talking now?
So
Tijani Akintunde, right?
yes, sir. Tijani Aki today.
Okay, explain for question number 1.
Okay, sir. We have our second term to be 18, and we have our fifth term to be 2/3. So by my solving here, you say t, because we are using the formula Tn is equals to ar raised to power n minus 1. So
yes,
we say t2, which is the second term, is equals to 18.
T2
So yes,
equals to
t2.
18. Yes.
Yes. So we now say 18 is equals to ar raised to power, the n is the second term, which is 2 minus 1.
AR raised to power 2 minus 1.
2 minus 1. Yes, sir. So when we solve that part, it will be 18 is equals to ar raised to power 1, which is TAR. Then we'll do the same for
Yes,
the
we are doing it. We do the same for T5.
Yes, which is
2
2/3.
2/3
is equals to ar raised to power 5 minus 1, which is 4.
So just hold on, yeah. I hope other people are following the way it's explaining. So
yes, sir. Yes, sir. Yes, sir.
okay.
Yeah.
And let's
So then we're going to,
the other one is T5.
5, yes, which is 2/3.
Which is 2/3.
Sir,
Yeah.
can I ask a question?
I'm coming, please. Let's finish this. Let me finish this. 2/3 equals to AR4. Okay.
Yes.
Yes.
So after this one now, we're going to do simultaneous equation. Should I continue?
Yes. After simultaneous equation, you will get A.
Yes, no, we are going to cancel out the A.
Just
So
divide
It's divide, not
you divide the bigger equation by the smaller equation.
Yes, it's the same thing. I said we're going to cancel out the A. If we divide it, A, we cancel A. So it will be.
So you now have R4.
R cube.
Yes,
R4 over
R will be R is 1/3. R is 1/3.
R is 1/3.
Yeah, I got
it. Trying to write this stuff.
Sir.
So eventually you get. I'm coming, please. You get
the second term is minus 18, please.
You get
minus
1/3.
According to what is given, it is minus
Sir,
18.
there are different ways of solving this.
1/3.
Sir, there are different ways of solving this. You can
I think. Hello, you that is
listening,
talking. I didn't call you are talking. I think it was Akins that was talking.
Yes, sir.
And somebody said there are different ways. Allow him to finish it with his own way now. Before you say your own method, just cutting. So you now get R to be 1/3. So that means it is minus 3 that is here. Because in my own answer I have minus 1/3. That means it's minus 18 here.
Yes.
So if you use minus 18, you are going to get R equals to minus 1/3.
Exactly.
So then you later come and get A, right?
Yes.
So maybe your A will now be 54.
4.
So and you come back to the formula T and A is 54 times. That is a method which is fine. Okay. That's somebody said that another method. Tell us that method.
Sir, like
once
you have gotten.
Is that Eromosele?
Yes, sir. Yes,
Who
sir.
is talking?
Me, Eromosele.
Now let me. Eromosele, okay. Let me hear you.
Sir, like he said in firstly, he said T2 is equals to AR. That means the second term that is equals to AR, and the fifth term is equals to AR raised to power 4. So in that you can so you now put minus, like AR is equals to minus 18. Then you can now put, like, now you can now do A, you subject of formula, you now do A is equals to minus 18 divided by R. Then put it in the other equation, then you can get your answer like that. That's what I was trying to say.
Okay. So which you are also very good. So that is very good. Okay. So thank you. Yeah, I think you understand what he said. Just get from here, just get your he or your R. A is easier to get here in terms of 18 and R. Then substitute into this equation. So now, but the question is, you want to find the general formula. Is it? How will it? Okay, yeah, definitely. So you put that and you get your answer, like a TN. Okay. The second question here, given the, let me clean this. Okay, given the geometric, so let's look at the number 1. We have done number 1. So number 2, given the geometric sequence 5, 15, 45, find the next 2 terms. Find the next 2 terms and the 7th term. So how do we find the next 2 terms here? We know, can we find A and R? What is
Yes.
A?
Find A and R.
A is 5.
5. And our R is
R is 3.
Our R is 3. So what is going to be the next term? 45 times 3?
As AR is
135.
And the next time is 45 times 3 times 3.
405.
So now find the 7th term. So
The 7th term is 3,645.
Okay, so that is 7th term. Thank you. So this is the number 2.
5 times 3 6 18 15 6.
Now let's go to number 3. The third term of a GP is 10, and the 6th term is 80. Find the common ratio and the 10th term. The third term of a GP is 10. The 6th term is 80. Just like the example that we did the other time, you find T10 using the formula. This formula Tn equals to ARN minus 1. To find T10, T10 will be 5 over 2 times 2 raised by 10 minus 1. Then the system is 80. Find T6. That's equation 2. Then you do that simultaneously to get your E and common ratio. And then you apply Tn again to find the 10th term. So the 10th term, yes. So this is the formula. You find the T3, you find T6. Solve this simultaneously to get your A and R and substitute. So if I'm correct, my A is 5 over 2 and my R is 2. So this is, yeah. So this one will be, if you simplify this, it's going to be 5 times 2 raised to the power 8. 5 times 2 raised to the power 8. So this is what your answer will be. You can calculate it and get the answer. What is the answer? 2 raised to the power 8 times 5.
1000. 280.
1280.
1000.
So is it 2 raised power 8 or 2 raised power 9?
It's 2 raised power 9.
Yes, I have 5/2 times 2 raised power 9.
200 will remove one of the 2 from 9 now, so it will remain 2 raised to the power of 8. So it's 2
So
raised to the
5/2 times 2 raised power 9. So by the time you simplify, it becomes 5 times 2 raised power 8, and then you get this.
The answer is 320 now.
So is it 320?
1280.
1280.
So this is what they tell me, and that's what I'm sticking to. I don't know whether that's correct or not. Okay. Let's move on. Very soon. We need to the sum of let us look at the sum of n time of a GP. The sum of the term of GP is called geometric series. I mentioned it the other time. When you sum, that is geometric series. We can now write the sum of the first n terms of geometric series as Sn equals to first term A plus second term, which is AR, plus third term, which is AR2, plus fourth term, which is AR3, up to the last term, which is ARn minus 1. Sn is this. So that is the sum. You can simplify this. For example, the sum of the first 5 term of a GP with the first two, with first term 2 and common ratio 3. If you are using this formula, the first term is 2, the common ratio is this, you do all of this, and you begin to add it. But we now say that if n is a very big number, when n is large, you need a more systematic approach for calculating the sum of given number of terms, given the number of terms required. Meaning that you can find a better formula rather than adding term by term. And by that, we get to this formula. This is the procedure. If you have this, if I multiply by R, I have this. If I subtract this, the second equation from the first equation, I simplify, I have this. And by that, if I factorize Sn, I will have Sn into R minus 1 equals to Arn minus 1. Let me take time and explain this so that you understand the derivation of the formula. If from here, I said the sum is this. You are adding all the terms. So that is what I now have here. Starting with first term and common ratio, the sum is given as this. But we want to find the formula for general n. So what we do is that you multiply both sides of this by common ratio R. So the first one here, you have R multiplied by Sn. Then you have R multiplied by, which is AR. R multiplied by AR, which is AR square. And so on and so forth here. So what we do now, this equation 1, this equation 2, let's say I subtract equation 1 from equation 2. From left hand side, I have RSN minus Sn. Then the right hand side, I have all of this minus all of this. So A, it will remain minus A. AR will cancel, AR minus AR will cancel, AR square minus AR square will cancel, all of this will cancel. Only what I will have left, it is AR and A. So I have ARN minus A. So I factorize here, Sn is common. This is Sn into R minus 1. Here A is common. I take A out, I have Rn minus 1. So what do I have next here? I can now compute Sn to be what are we going to have? A to Rn minus 1 in the bracket divided by R minus 1. So this is the formula that we use for R when R is greater than 1, when the common ratio is a positive number. R is greater than 1. So this is the formula, okay, that we'll be using. And this is how to derive that formula. And that is what is written here. Sn is equal to Arn minus 1 over Rn, R minus 1, where R is bigger than 1. What happens when R is less than 1?
The reverse should be the case. It will be 1 minus R raised power n over 1 minus R.
1 minus R raised power n.
Okay, what if can R be 0?
No.
No, sir.
No, sir.
Common
No,
ratio
sir.
cannot.
Division
Common
is
ratio.
invalid.
No.
There will always be a common ratio.
Yeah, must always be a common ratio because you can't, you know, you are divided by common ratio or you are multiplying by common ratio. You can't divide by 0. You can't, if you multiply by 0, everything will just be 0. So if common ratio is 0, that means you don't have any sequence. So with this, we are now saying if we multiply the numerator and the denominator by -1, we can write the sum to be this. And this is when R is less than 1.
Okay.
So this form is useful when absolute value is less than 1, since it affords the use of negative number. So let's quickly look at the following example. For the first one, find the sum of the first 12 terms of the series. This is the general form of the series. Find the sum of the first 12 terms. Number 2, find the sum of the first 5 terms of the series 5/3 plus 5 plus 15. Then number 3, given the geometric sequence 6, 18, 54, find S7, sum of the first 7 terms. This is what, in fact, look at the solution of number 3 is here. In this case, A is 6, common ratio is 18/6, which is 3. And since common ratio is greater than 1, we can use that formula and you'll be able to get S7. So let's see the solution of the other 2. So this is the formula you are using. Okay, Sn is equals to A into 1 minus Rn. That's what I mean by A1 times A1 Rn, 1 minus R. Or you change the order depending on what your R is. So in this case, in case number 1, who can tell me what our first number is? This is the general term. What is A?
A is 4.
4. A is 4.
A is 4.
4, sir.
A is 4.
A is 4.
If I tell you that you are wrong, A cannot be 4 now. The general term is given. The general
1.2
term
now.
1.2.
1.2.
General term is 4.
What is general term? The first term will be 4 times 0.3 raised to power 1.
And then equals to 1.
So our A is 1.2. What is our R? You can get the second term. The second term will be 4 times 0.3 raised to power 2.
Yeah.
And once you get the second term, you can find your R. So that is what brings about the formula I'm writing now. Look at it. 1.2, that is the first term, multiplied by 1 minus R raised to power 12. So that's what you have there. So our R can be calculated to be 0.3. So using that formula, 1 minus 0. So we use this because R is less than 1. So when we calculate this, this is what I have, 1.7.
Sir, excuse me, sir.
Yes.
Sir, please, I don't understand how you got that 1.2. I'm confused. Is it that you multiplied 4 times 0.3?
How do I get 1.2?
Yes,
now just let me explain. Tn is what is given is Tn.
Yes, sir.
Tn is given 4 times
0.3
raised to power n. That is Tn. So what is your A?
A is supposed to be 4 now.
A is when n is 1, sir. That's 4 times 0.3.
A is when n is 1. A is T1. Or you call, let me just call it A1. Let's say so that you understand. Let's call this one AN.
Sir, thank you so much. Thank you, sir. I understand, sir. I understand.
So A1 is 1.2.
Yes, I don't want you can continue now. Sir, you can continue.
Yes, it's okay. It's okay. Let me do it because of others. What is our A2? You put 2 here.
A2 will be 4 times 0.3 times 0.3.
4 times
It will be 0.12.
Is 0.3 raised to power 2.
0.36.
So I will say it's 0.3 raised to power 2. What is my common ratio? Common ratio is A2 over A1. So that's how we get common ratio. And my common ratio is going to be 0.3. Because I will just say A2, my A2 is this. Divide all of this by 4 times 0.3. 4 cancel 4. 1 is 0.3 cancel, 1 is 0.3. So my common ratio is 0.3. So, and I'm going to use the formula A into 1 minus Rn over 1 minus Rn. So this is the formula that I'm using. And this is what I will have. What I have here. And when simplify, I get this. Okay. Now we proceed. Oh, what happened? So, number 2. What is our A? Our A is 5 over 3.
5 over 3.
What is our common ratio?
5 over 3. 3.
5, 7,
3.
that is 3. 3 is common ratio smaller than 1 or bigger than 1?
Bigger than 1.
Bigger than 1.
So which means we are changing this formula.
Yes, sir.
Right? The other
Yes,
way
sir.
around. So we change this formula the other way around. So when you do that, this is what I have. 605 divided by 3. Okay. Meanwhile, if you use this formula here, you will still get the same answer because you will get negative in the numerator and negative in the denominator, and we cancel each other. So for number 3, which I explained the other time, you have this and use this formula. So that is that. Yes, let's look at this. Sum of GP to infinity. Sum to infinity. If you want to find sum to infinity, you have infinity. This is the formula. This is the formula down here. I recall this is the formula for when R is less than 1. This is the formula for when R is greater than 1 for finite series. So the formula are not valid when R is not equal to 1. So if R is less than 1, sorry, the formula are valid if R is not equal to 1. So if R is less than 1, R raised to power n, if you find the limit of R raised to power minus n, it will be, this number will be going to 0. If R is a negative, is a smaller number, is a fraction. If R is a number that is less than 1, when you take the limit, that R is becoming smaller. So as n is becoming bigger. The meaning is that when you are finding S infinity, that in this case, instead of Sn, infinity means a very large number. It means as n is growing very big. And as n is growing very big, our Rn will become 0. So if we use this formula, the formula that I have here, if we use this formula here, where I see n, I put infinity. So that is S infinity. Where I see Rn, that is as n goes to infinity, Rn becomes 0. I put this. And this is the formula you have. So the sum to infinity is A over 1 minus R. So this is the formula you use when you are finding the sum to infinity. Because R raised to power n is tending to 0 as n is tending to infinity. So you should be able to do the second and fourth. I want to, in 5 minutes time, I will be rounding off so that you can be able to attend if you have another class. The second and fourth term of a GP of positive term are 9 and 4 respectively. Find the common ratio and the first term. Then find the sum of the first n term of the sequence. Oh, fantastic. This one is tricky. You know the formulas for the common ratio, you know the first, You do it, find simultaneous equation to get common ratio and the common and first step. Then you do the formula to find the sum. So, and that is what I try to illustrate that here. I have these two equations that I solve simultaneously, and I have the common ratio is 2/3, and the first term is 2/7. Okay. Meanwhile, maybe by the time we solve this, we may resort to having two different solutions because you may have quadratic equation here, and you are getting two ratios, two common ratios. Maybe one is positive, one is negative. You will come back to your question, check whether the term of whether the terms of your GP are negative or positive. If the terms are positive, common ratio will be positive. If every term is negative, common ratio will be negative. But in the situation where you are having positive and negative alternating, then common ratio will be negative. So in this case, our first term is 9. No, our second term is 9. Our fourth term is 4. So which means we have positive numbers. Common ratio will be positive. So by the time I solve these two equations, I will have two common ratio, plus or minus. Because you take square root, it's going to be plus or minus. But I will only stick to positive because my common ratio, I am sure that is going to be a positive number. So the common ratio is 2/3, and I will use that to find the first term. And I will use this formula to find the sum of n terms. Since R is 2/3, which is less than 1. So when I substitute my A and my R, and I simplify that expression, I have this formula. This is the formula that I have. Okay. Maybe 81/2. 81/2 into 1 minus 2/3 to the power of n. So this is the formula that I have. Okay. So these are another examples which you can look at. I'm moving on. Find the expression for this partial sum. So I have the following question as practice exercise, which you will take home and practice.
Will the slides be available?
Yes, I will send you the slides.
Okay, sir.
I will.
Sir, can we get your WhatsApp number?
Okay, no problem. So you have this practice exercise as classwork. Then we have this as exercise. So look at this exercise. Okay. This is number 1, number 2, number 3, number 4, number 5. So with this exercise, we are coming gradually to the end of the lecture. So we have question and answer session. Then we don't need to go to question again. I've given you enough time to ask questions during the course of teaching. So please, how do you take your attendance?
The course will create a Google file, sir.
Okay, the course will create a Google file. Please,
yes, sir.
Make sure that you take that attendance, and I will get it. So,
sir, your WhatsApp number.
My WhatsApp number. I will give you my WhatsApp number as my final comment. My WhatsApp number is 081.
No, because of you, I did not charge Saturday night.
081, sir.
It's 05.
I know, did not open door.
26 2085. So,
yeah, please can you call it again? Okay, I've seen it.
It's on the screen now.
It's 081 05 26 2085.
85. Yes, sir. Thank you, sir.
Yes, sir. Thank you, sir.
Excuse me, sir.
Thank you, sir.
Yes.
I have a question
Thank you,
in
sir.
slide 27.
Slide 27.
Yes.
No go lose guard.
Yes.
For number 4, why did you say that is not a geometric progression?
Now, a geometric progression have common ratio. Like number 3 now. Look at number. Let me before I come to number 4. Is number 3 a geometric progression? No.
No.
Look at number 1. Geometric progression have common ratio. That is, if you say second term divided by first term, it must be the same as a third term divided by second term. It must be the same thing as a fourth term divided by third term. So, like in this case, now 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. Therefore, this is a GP. Look at this. 36 divided by 2. And 36 divided by 12. 3. 108 divided by 36. 3. 324 divided by 108. 3. This one has common ratio. But this one, 4 divided by 1, 4. 9 divided by 4. Is it 4? 16 divided by 9, is it 4? So this one does not have common. There's no common ratio.
The number 4 size.
Look at number. You see, does it have common ratio? 1 over 9 divided by minus 1 over 3. I think that is minus 27.
No, it's minus 1 over 3.
Yes.
1 over 9. 1 over 9. 1 over 9. Divided by 1 over 3, minus 1 over 3. That will be divided by minus 3 over 1, right? And the answer is minus 1 over 3.
Minus 1 over 3.
Right?
Yes, sir. Minus 1
Let's
over 3.
end this class. I beg.
Let us look at this. Minus 1 over 27. No, this one is time. Sorry, I want to put that. Minus 1 over 27. Minus 1 over 27.
Yes, sir.
Divided by 1 over 9. That would be times 9.
Wow.
This is minus 1 over 3.
Minus 1 over 3.
Minus 1 over 3.
Yes, that because 1 over 3, 1 over 3, that doesn't make it a GP yet. We have to check the fourth one. I mean the third one. 1 over 67. 1 over 61. 1 over 61.
Not 1 over 61.
And what do you say?
1
over 61
times 27.
times minus 27. This is what you have here. Does this have a common ratio?
No. No, sir.
So there's no common. So that's why we say it is not a GP, because it does not have common ratio. So thank you for listening.
Thank you, sir. Thank you, sir.
Thank you, sir.
I've come to the end of the
Thank you, sir.
Thank you very much, sir.
Thank you.
Thank you,
Thank you, sir.
When next, sir?
Thank you so much, sir. Thank you so much, sir.
Thank you, sir.
Yes.
Thank you, sir.
To when
Okay.
next, sir? Thank you,
Yeah. What is it called? The exam officer or the coordinator will get in touch with you.
Okay, sir.
Okay. Yes, I will send you the
slide.
Slide. So thank you. I'm leaving the meeting.
Bye, sir.
Bye, sir. Bye, sir. That talk will finish me.
All of now we they ask stupid question. They turn out go fire on her for me.